All right, so like I said, we're going to start with that question that I assigned in the packet for the percent yield, calculating the percent yield from yesterday. And so you'll need yesterday's notes packet. You should notice that I have two things on your desk today. The first thing is the study. Well, one thing is the study guide. That's kind of go through to help you kind of see what concepts are on the test. And then the second one is our notes for today. So as we go through, we will kind of finish it out today. So take a minute, make sure that you have number 3 done, and then we'll get started. Well, I take care of a few procedural things. All right. All right. So looking at this from yesterday, this is where we ended up yesterday, that we were calculating percent yield. We were also calculating theoretical yield. Remember, theoretical yield, even though the definition of it says the maximum amount, if you're ever doing a limiting and excess, it's actually going to be the smaller amount that's created, because that is the maximum amount because of the limit. So remember that. Now, a lot of times you won't have the limiting reactant, but just make sure that you recognize when it's there. All right. Or it won't tell. It'll tell you that you have this much of this, and then it'll say in excess of the other. So don't freak out when that happens. All right. So the question today says to prepare the paint pigment chrome yellow, lead chromate. A student started with 5.552 grams of lead nitrate and an excess of sodium chromate. So whenever you see where it says excess of something, that's just telling you that's going to be the stuff that's left over. You have more than you need. So the main ingredient that we are worried about is this one. And then we also want to find that. All right. And it tells us that the actual yield of PbCrO4 is that. So remember, percent yield is calculated by actual yield over theoretical yield times 100. So we already have part of this equation. We already have the 5.096. And so we're trying to solve for theoretical yield first. So to solve for theoretical yield, I'm going to take my given 5.552 grams of lead nitrate. I have to get, no matter what the calculation is, if we're not given something in moles, we have to get 2 moles. So whatever steps it takes to get to moles, we have to do. So now I need the molar mass of lead nitrate. By now, I know this was kind of a new thing, but by now we should have done enough molar masses that it should be just kind of starting to get to be second nature that you're doing it. All right. So I'm going to add the mass of 1 lead, 2 nitrogens, and 6 oxygens. We get 331.22 is what I got. All right. Because nitrogen is 14.01. and there's 2 of those, and then lead is 207.2. It probably won't affect your answer that much, but remember, molar masses always want 2 decimal places, even if it's a 0. All right, now we need to do mole ratio, which in this case it happens to be 1:1. Just make sure that you're always verifying that. Technically, as far as the math is concerned, as far as the multiplication and all that, that doesn't matter. But unit cancellation, it does matter for us. And then our last step is I need to get 2 grams of lead chromate. No, 323.20. All right, so for molar mass of lead chromate, 323.20. So when we go through and get this calculation, I want to get my answer in 4 sig figs. So I get an answer of 5.418. All right. Now, this number is what I'm going to apply right here. So 5.418. And so this is a step where you can kind of check yourself too. If you're being asked to do this, and if this number is not smaller than this number, there may be a problem with your math or your setup up here. All right. It's okay if they're exact. That would just be 100%. But if it's if this number is not slightly larger or significantly larger, there's a problem. All right. So going through 5.096 divided by 5.418, maintaining 4 sig figs, you get 94.06. Where did it go? Well, because I was doing something. All right. So check your answers. Make sure you have that, and go through that. All right. So going into today's notes. All right. So this is the last part of chapter 8. It is still stoichiometry, but we're going to be using one more concept. So if you remember when we talked about exothermic and endothermic, we're bringing that idea back. And so we're going to start putting that temperature, that amount of energy back into it. Yes?
Sorry, that's a question for the last problem. So on the active, there was one where we needed to find percent yield, but we didn't, like it didn't give us the actual yield. So is there a way for us to
after we go through the notes, let me look at that one, and I may pull it up and I'll have to see, because I have to see what's there.
Because I did all the steps and then I was like, oh wait.
Yeah, let me. I'll have to pull it up and see, because it may be a problem with the actual question. All right, so I'll pull that one up later. All right, so today we're going to be looking at calculating the amount of thermal energy emitted or absorbed by a chemical reaction. So I went ahead and gave you the notes again. Just because today is a shortened day, I want to make sure that we're not just writing things down, but we're paying attention. I will make some marks on here, so you might want to add those to your notes as we go through. All right. So when we're looking at chemical reactions, recall, and I may have actually given you this exact slide before, like a couple of chapters back, but recall that we can have reactions that are exothermic, meaning, so exo means that heat is released or exits. All right. Now, when it comes to the heat energy, so if you remember, we were calculating heat energy earlier in the semester where we say Q equals MC delta T. Q represents a heat energy. Remember, it was usually measured in a unit called joules. Today, we're primarily going to be focusing on a unit called kilojoules. Another way that we can write heat, Q, is with the symbol called delta H, or change in heat. And so if I am releasing heat from a system, is that heat going to be negative or positive as far as its flow? If it's leaving the system, negative. So exothermic, when you see a chemical reaction that it has a heat associated with it, or a change in heat associated with it, if you see a negative number, that means it's exothermic. For endothermic, heat is added to the system. So in terms of delta H or Q, what are we going to expect the overall, not charge, but overall direction of it to be? Positive. It's added. Now for the positive sign, we're not going to show the sign. Negative, we would show a sign. But I'm going to talk about some things because we have to be very careful when we read the question to see if it's asking for absolute value or if it's asking for direction. So these questions can be kind of tricky. From what I recall, I don't remember seeing one where they ever ask you to put the negative sign in the test, but there's always a possibility. So if you're ever concerned, call me over. I will kind of verify whether it should be a negative sign or not. I'll try to read the question to the best of my ability. And if not, I'll argue for you at the end. All right. So the whole thing is we're looking at the amount of heat energy that's either absorbed or released during a chemical reaction. And so this particular study in chemistry is called enthalpy. Enthalpy is just kind of very, very simplified. It is the study of heat exchange or heat reactions. The study of heat in chemical reactions. All right. So, already kind of talked about this. The sign of delta H can be positive or negative, and it depends on the direction in which the thermal energy is flowing. So I'm not really looking at it being a negative number or a positive number. I'm looking at it in terms of, is it going into the system or out of the system? If it is flowing out of the system, if it is exo, then we're looking at a negative sign. So that's why we say that would be a negative delta H. If it is going into the system, or endo, that's where we get the positive sign, and that's when we say that it is a positive change in energy or positive change in heat. remember, as far as chemistry is concerned, heat equals energy. The terms heat and energy are synonymous. They are the same thing. All right. So, and again, I think I've shown you these graphs in one form or another before. So when we look at what's actually happening in the reactions in terms of energy.
Oh, with the squiggly line.
Yes. So these are kind of heat exchange graphs. It's showing you the change of heat in a reaction. So if I have my reactants, A plus B, and my products, AB, at the beginning of the reaction, so in the products, in the reactant side or the product side, which one of these has more energy?
The top, the product.
The
reactant.
Reactants has more energy to begin with because we're up here on the graph. All right. The products have low energy. So that means that as that reaction flowed, that we had a change in energy. And that was a negative change in heat because it went, the overall energy lowered. All right. So if we look at this one, the endothermic reaction, all right. Now when we look at it, if we look at it in terms of an endothermic reaction, what has more energy, the reactants or the products? Products. So in order for this to happen, we had to get the energy somewhere. So we had a positive change in energy. We had to add energy to it to make the reaction happen. So, you can kind of think about it. If you remember back in middle school or elementary school, if you ever covered Newton's law, 3 laws of motion. And we talked about, you probably talked about potential energy versus kinetic energy. Up here, this has a lot of potential energy. And so to get down the hill, it rolled down the hill, it lost all that potential energy. So the energy went somewhere. It went to heat, it went to light, it went to sound, whatever. But we have less energy in the ball now than we did at the beginning. Here, we have to get the ball back up to the top of the hill. So we have to physically lift it and carry it or roll it back up the hill. And so we have to give energy back to it. So when it's on top of the hill, it has that potential energy again. All right. So now, inactive, I want you to look at these questions. Now, when you're looking at your question, pay attention. Your numbers are not going to match mine. All right. They might, because there's a random algorithm that it could match mine. But odds are your numbers are going to be different than mine. So I want to look at these. So now notice, what do you notice different about the chemical reaction here versus the ones that I've seen in the past or shown you in the past? We have an added factor of the heat. And some of you, if you have a wider screen, the heat might actually be written right here instead of below it like it is on mine. All right. That's so first off, the first question I want to ask about this, we see a negative number for kilojoules per mole. So is that endothermic or exothermic? All right. Remember, a negative heat is associated with exothermic. Now, we have to be careful in reading these questions as to understand what the answer should be. All right. It says, what is the quantity of heat in kilojoules released? All right. So whenever I see that word quantity of heat, think absolute value. So we're not looking for a sign on this one. I don't care about the positive and negative. I'm going to use it in my math, but at the end, I don't care about that. I just want the quantity, the total amount. So now, we do this just like any other stoichiometric equation. It gave me moles to start off with. So I have 3.15 moles on my example. It tells me it's CH4. So what is the only thing in the chemical reaction that I'm going to be looking at as far as coefficients or anything like that? CH4. All right. So I'm in moles of CH4, so that means I can immediately go to my mole ratio. So my coefficient in front of CH4 is 1. So I have 1 mole of CH4. And it wants to know the amount of heat released in kilojoules. So I have anything that tells me kilojoules. The negative 802. So if I would have had a coefficient of 2 in front of CH4, I would have put a 2 on the bottom there. But since I didn't have a coefficient of anything, I just used the 1 mole. So I'm going to do my math here. And whatever I get, the absolute value of whatever I get is going to go in that blank. Now, again, if you're looking at your problem in active, pay attention. You probably don't have 3.15 moles. All right, you probably have something else. Now, the other thing to pay attention to, how many sig figs is this? Your answer has to be in 3 sig figs as well. So if this is something 1,437 or 28, then it's 1,430 is 3 sig figs. You know, so pay attention to those kind of things. Let me see what I got. I got negative 2,530. So I round it like that. I knew it ended in 30. I just couldn't remember what the original answer was. All right. So take the absolute value. So that means we're dropping the sign. If you were to write it with the negative sign in there, it's going to tell you while the quantity is right, while the magnitude is right, the sign is wrong. And so that's just telling you to drop the sign. Yes, ma'am. You can do it in scientific notation. So that would be like 2.53 times 10 to the third. Yeah, it's going to show it in that because, and the reason why they do that is because remember the 0 sometimes can be ambiguous, so it could count or not. So this is actually a better way to state it to get exactly 3 sig figs. I don't like punching in scientific notation, so I write it the other way. Yes.
The one I was talking about is right before that. I don't know.
I'll get to it. Let me get through these because I'm kind of wanting to do these with y'all, and then I'll come back to that other one. All right. And also because I don't have it in my slideshow. What quantity of heat in kilojoules is absorbed in the process of making 0.841 mole of CF4? So the kind of key word here, I'm absorbing heat. So when I see that word absorbing heat, what does that tell me about? Is it endo or exothermic? It's endo. All right. And that should make sense because what do you notice about our delta H this time? It's positive. All right. So again, I have 0.841 mole of of CF4. And I look at CF4, I have a coefficient of 1. So that means 1 mole CF4.
This is like easy. This is like easier than like every chapter.
All right.
Good.
All right. Now, so what if instead of asking for a carbon tetrafluoride, if it had asked for just fluorine, what would I have put on the bottom of that? A 2. All right. So it does go by coefficient there. You solve it. Answer needs to be in 3 sig figs still. So kind of pay attention to that. Again, make sure that you use your number from active and not my number. If you want to do it on the notes, or if you just want to check, I got 119 kilojoules because it was like 118.7 or something like that. All right. Number 21 is the same as 19 was. So I'm going to just point it out again. It says what quantity of heat. So that means absolute value. When we do this, the only difference in this one, what do you notice about your starting points? You have 2. So what type of question is this? Limiting reactant. All right. So that means we're going to have to do it twice. 1.20 mole of SRO. All right, because there's a coefficient of 1. And then I do 0.867 mole of CO2. And then ultimately, which answer do I pick from the 2 answers I'm going to get? Smaller amount. All right. So again, this one was a limiting reactant question, even though it wasn't asking about limiting reactant. It was asking for a limiting reactant based off of a theoretical yield. All right. And then number 22 is doing the same thing, but this time we have drop and drag stuff. All right. So now, so looking at this one, comparing this one to the 3 previous questions, what's different about our given from the 3 previous? Saying grams. So that means our first step is to get from grams of CH3OH to mole of CH3OH. So that means grams of CH3OH for every 1 mole. And then I would drop that 3.24 here. What I'm not looking for the specific number, but what do we call the number that we're putting down here? So I'm putting the molar mass of CH3OH there. Now, I'm in moles now. So since I'm in moles now, I can use that. My mole ratio is going to be based off of that. So I have mole of CH3OH to kilojoule Now, looking at my balanced equation, what am I going to put for my mole ratio here? 2. Since I have a coefficient of 2 here, that means I have a 2 there. And then I get my answer in kilojoules. All right. All right, and so the last two questions, the last two questions in this is 23 and 24 are done similarly. These, the next two, you don't really have to do any math to solve them. You're just looking at what it's asking. All right, I'm about to pull this away, so if you want it, take a picture or go back to the recording later. All right. All right, so looking at number 23 and number 24. One's going to ask this question based off an exothermic, one's going to ask it based off an endothermic. So I'm looking at this one, and it says, which one of the equations below is endothermic? So if I'm asking about endothermic, what is the only thing I really need to pay attention to? I need to pay attention to delta H, and it's supposed to be a positive delta H. So I look at my choices, which one of these represents a positive delta H? C. All right. That's the only one that's positive delta H. Because every one of those is negative. The other one is probably going to be the other way around. All right. So that is that's it for chapter 8. For the remainder of class today, you should be able to work all the problems in chapter 8 active. I'm going to look at that one. I'm going to pull it up. I just got to pull it up on my screen. I'm going to look at that other one just to see what's going on with it. You should be able to work on that. You can work on your study guide that I've given you. At some point today, I will release the quizzes that you can start taking like practice tests with it. All right. The chapter 7 and 8 quiz in Moodle, the practice quiz that's in there, so you can see how the professors might write the questions. The password is Southeastern 4 in the percent. The S on Southeastern is capitalized. I will post that in the notes thing today as well. All right, so let me pull up that other question and see what it is.